Hi, somebody requested problem number 61 in chapter 11. So I've got that one up on the board right now. Starting over here, the problem involves calculus, so you might want to look at this. There could very well be one of those coming at you on the next test or quiz. But the way this one goes is this: you've got a particle, they tell you it's got a mass of 1/2 kilogram. This should be kilograms. So 1/2 kilogram. And it's being acted on by a time varying force. Okay, so the force changes with time, and the force is this function right here. So you've got a constant term, 4 newtons of force, minus 1 Newton per second squared times t squared, where t is going to plug in values of seconds in there. And let's see, this force is going to be applied to this, to the object with this mass over this time interval from t equals -2 seconds to t equals +2 seconds. So I went ahead and graphed that function as a function of time. So here's the force function, and it's a downward opening parabola. It's got a t squared term, negative, and its vertex is at 4 newtons, and it hits a 0 at plus and minus negative, or -2 and +2 seconds. So that's the force as a function of time acting on this 1/2 kilogram object. And they also give you the initial speed is -5 meters per second at time equals -2 seconds. So right when this force begins to act on the particle, it's already moving at -5 meters per second. And what they want you to find is the velocity at the 2-second point when the force stops acting on the particle. So this time varying force is applied. It changes the momentum of the object. We can use the impulse. Oh, by the way, the area underneath this curve is J, the impulse acting on the object. So here's the impulse on the object. It's equal to the time derivative of, integral of the force function over the time of interest from t equals -2 to t equals +2 seconds. So here we plug in the function itself, and this is, it's a simple binomial that you have to integrate. And also, the impulse acting on the particle has to be equal to its change in momentum. That's the impulse momentum theorem. And that change in momentum is going to be its mass times its final velocity minus its mass times its initial velocity. Got a plus sign here because it's negative of a negative. Okay, and I plugged in the values that we have, and here's the unknown, the final velocity at time equals 2 seconds. So I go ahead and do the integration and evaluate, and this first term, when you evaluate it over the limits, you get 16 Newton seconds, and the second term cancels out. Okay, so the second term here, when you integrate, you end up with 0. You've got a negative term and a positive term that cancel. So this works out to a total impulse acting on the particle of 16 Newton seconds. Okay, and then you set that equal to its change in momentum, right? And so what I'm doing here is I'm going to multiply by 2 to get rid of the 1/2 and divide by kilograms. So 16 Newton seconds divided by 1/2 kilogram turns out to be 32 meters per second. And now that's going to be equal to the velocity change. So let's subtract the 5 meters per second initial velocity from both sides, and you've isolated the final velocity to be 27 meters per second. So that was problem number 61, and that's one of the few in there that really requires integration. And you should expect to see that because the basic definition of impulse or change in momentum can be expressed as an integral. So don't be surprised to see that. And I wouldn't throw any kind of integral at you that, well, actually you can handle any kind of integral if you're at home, right? But You won't see any nasty ones anyway. So, okay. That's it.